Welcome to the Module 12 Statway review. Module 12, unfortunately or fortunately, depending upon your viewpoint, is really not concerned with statistics anymore. It's the one algebra module in all of Statway. The reason that we need to have this module is for the transferability of the course to UC or Cal State. Now, let's go back to something we looked at in Module 3. Okay, we looked at lines of best fit, also called the least squared regression line. Now, we have two types of concepts. One, let's look at the line on the left. This is a plot of credit hours taken at school, in other words, number of units, versus tuition. Now you can see that all of the data points form a perfectly straight line. Each X, which is credit hours, has only one possible Y value. It's an exact formula to compute your tuition cost if you know the number of units that you're taking. This is called a mathematical function. On the right-hand side, we have a plot of credit hours versus book cost. Now here you know intuitively that different classes have different textbook prices. Now, you can see that here, not all of the data points are on the line. There's a lot of scatter. This is a statistical model. Now, a statistical model is where every X can have more than one Y value. Yes, it'll only have one Y value from the line of best fit, but the actual data points, if you look right over here, okay, around 9 units, there are 3 possible Y values for the same number of units. Okay, so how do we get the equation of a line? So the first thing is, okay, Gary borrowed money from his father. He's repaying his father the same amount each month until the loan is paid off. Now, after 3 months, that's your X, Gary owes $224. That's your Y. After 7 months, Gary owes $160. Okay, so X is the number of months that have gone by. Y is the amount or the balance still owed. How do we get the equation for Y in terms of X? Now, the very first thing is we come here to slope, and it's the change of Y's over the change of X's. Now, whatever order you do the subtraction of Y's in, so here I'm doing the second Y minus the first Y. I have to do the exact same order for the subtraction of X's. Second X minus first X. So my slope is negative 16. Now remember what slope means. As X goes up by 1 unit, how much is Y going up or down by? So Y is going down by $16, which makes sense. Every month that goes by, the loan is getting paid off, and the balance is going down by $16. Now we know the equation of a line is Y equals mx plus b. So now we know the m. The m is negative 16. Okay. Next, in order to get the b value, take one of the data values. Either the x is 3 and the y is 224, which is what Statway chose, or you could have chosen the x is 7, the y is 160. Okay, so plug in x equals 3, y equals 224 into y equals mx plus b. Solve for b, 272. Okay, so now we know the formula. Y equals negative 16x, that's your m, plus b, 272. Now, if we want to know the amount owed at 1 year, remember, X is in months. So 1 year is 12 months. Plug x equals 12 into the formula. So the amount owed after 1 year is $80. Next, we're going to look at something called proportions. A proportion is where instead of having y equals mx plus b, there is no constant term. It's just y equals mx. Y is a multiple of x. For example, suppose you go to the gas station and gas is $4 a gallon. Y is the cost. X is the number of gallons you buy. Y equals 4x. Okay, there's no plus b. That's a proportion. A proportion, when x is 0, y is 0. So here, if I buy 0 gallons of gas, I pay nothing. Now, Texas has a sales tax on most products. And here we have a table. Okay. And we want to know, is this a proportion? Well, it's a proportion if you take y and divide it by x, and you get the same m, the same constant of proportionality for all of the data points. So let's take y, 0.32, divided by x4, that's 0.08. Take another data point, 7.20 for the y, divided by the x, 90, 0.08. Then that's a proportion. And the constant of proportionality, or the slope, is 0.08. Okay, so here, as we saw, okay, it is a proportion, and if you had all different data values, okay, you take the y's over the x's, it should give you the same amount. What is the formula for y equals mx? In this case, y equals 0.08x. What would the tax be on a $40 cowboy hat? Well, 0.08 times 40, $3.20. If we buy a pair of boots that are double the price of the hat, would that double the tax? Yes. In a proportion, as you double x, then y gets doubled as well. Okay, so to summarize a proportion, okay, when one is 0, the other is 0. So when x is 0, the y is 0. Okay, one variable, y, is always the same multiple of the other variable, x. Okay, when one is 0, the other is 0. Slope is the same as the constant of proportionality. Now, let's look at where we may have to solve some equations. Alicia's cell phone plan costs $10 and she's allowed 200 text messages a month. Obviously a very old plan. She has to pay 25 cents for each additional text message. She could switch to the unlimited message plan, which only costs a flat fee of $20. Let X be the number of texts over 200, not the number of texts, the over 200. So, her current plan. Her cost would be the fixed fee $10 plus 0.25 times X, where X is the number of texts over. Now, 1 month, Alicia sent 300 texts. What is the value of X? Remember, X is the number over 200, so that would be 100. So, using the formula right here from number 13, the cost would be $10 plus 25 cents for each text, 100 over 200, $35. Now, obviously, the other plan, $20, would be more beneficial to her. She'd save $15 a month. Okay, so now she's thinking about switching. Where would the number of texts be where it would start to become beneficial to switch? Well, let's set the costs equal to each other. Let's see where they give you the same number. So you set 20 from one plan equal to 10 plus 0.25x from the other plan. And you solve for x. X is 40. Not at 40 texts, 240 texts. So over 240 texts, it's beneficial to switch to the new plan. Okay, let's switch our focus a little bit now from equations to inequalities. Inequalities are less thans or greater thans. So, we know that a car depreciates. So, let's say Mr. Lawson bought a car for $16,000. Each year the car loses the same value. Now the value they're calling W, the worth of the car. And it's negative 1,500x plus 16,000, where x is in years. Now here's a graph. Now remember what you could tell from the equation of a line. Slope is the number multiplying x. As x goes up by 1, the worth is going down by 1,500. It's losing $1,500 of value in a year. Now the y-intercept is 16,000. Remember, that's the initial value when x is 0. That's when we bought the car. Now, suppose we want to know when will the car's worth be less than 11,500. The horizontal line is the y value of 11,500. Let's look at our line. When is the y value less than 11,500? It seems to be starting at year 3. After 3 years, the value seems to be less than 11,500. Okay, now we're going to want to see how we could also do this algebraically. Okay, in order to solve an inequality, remember, get the x term alone, subtract 7 from both sides. Negative 3x is less than 39. Subtracting does not flip the inequality sign. Next, divide both sides by negative 3. Dividing by a negative, that flips the inequality sign. So you have negative 3x less than 39. Then divide both sides by negative 3. X greater than negative 13. Okay, next thing is, in this chapter, luckily it's a review, exponential models. So, the best course that I would recommend is to go back and watch my Module 4 video that talks all about the exponentials, which are talked about again in Module 12. Okay, and the very last thing we're going to look at, linear, quadratic, and cubic power models. Okay, these are proportional models. There's no plus b here. Y equals ax squared. Y equals ax. Y equals ax cubed. Okay, there's no constant term. So, how would you know if you didn't have the equation if something's linear, like this, quadratic, or cubic? Well, for linear, as the x doubles, the y doubles. Okay? If in a quadratic, as x doubles, y goes up by a factor of 4. And for the cubic, as y doubles, as x doubles, y goes up by a factor of 8. So let's look at this example. Let's try to figure out what it is. Okay. 10, let's look at two values of x which are double each other. 10 and 20, as x goes up by a factor of 2. Okay. Y is going up by a factor, take 10,624, divided by 1328, goes up by a factor of 8. So that's a cubic. And your formula would be y equals 8x cubed.